Welcome to Introduction to Human Geography. This is the first video lecture in a series of video lectures that you all will be watching over the course of the next 3 weeks. For this particular lecture, I would like all of you to read Chapter 1 in the textbook, especially pages 2 through 30. First off, I want to just give you a sense of what we're going to cover over the course of about the next 14 minutes. This particular video lecture is going to focus on maps, and we're going to do exactly two things. The first thing we're going to do is we're going to differentiate between what geographers call reference maps and what geographers call statistical maps. It turns out that statistical maps are much more important than reference maps in a course like this, although we will be using both. The second issue that we're going to address here is the issue of map scale, and most importantly here, what I would like all of you to be able to do before we get through this first module is I'd like all of you to be able to understand the difference between what geographers call a large-scale map and what geographers call a small-scale map. So, to begin, let's start out by looking at a really good example of a reference map. The map that you have right here is a reference map of the entire world. The reason it's called a reference map is because there's not a whole lot of information shown. There's really no data. There's really no statistics. Basically all you have is the outlines, the shapes, and the relative sizes of the countries of the world. So to just give one example, follow my cursor over here to Russia. You can see that Russia is a very large country. In fact, it's the world's largest by geographic area. I can also see that Russia has a border with Kazakhstan and Mongolia and also China. But that's it. There's no other information given. There's nothing about, for example, the politics of Russia, the economy of Russia, the culture of Russia, or the history of Russia. So reference maps, by their very nature, are basically kind of bare bones and skeletal. Not a whole lot of information given. Now, there is one other reason that I wanted to talk about reference maps, and that is the issue of how much geographic literacy students would need in a class like mine. Let me explain what I mean. Most American college students don't have that much in the way of geographic literacy. They probably know, for example, that this is North America and South America. They can identify the continents. But when it comes right down to the details, like for example the difference between Algeria and let's say Egypt, a lot of that is lost on most American college students, and that's probably true for college students all across the world. So the question becomes, how much geographic literacy do I expect all of you to know coming into the class? How much do I expect you to know if you're going to get a passing grade or a really good grade? Well, the answer to that question is kind of difficult to actually put out there, and let me explain why. You could probably do just fine not having that much in the way of a geographic literacy. But it's going to help. It's going to give you a leg up. And so here's my recommendation. On pages 6 and 7 of the textbook is a map that looks a lot like this one right here. It's basically a world political reference map. What I would like all of you to do is to spend maybe somewhere between 10 and 15 minutes looking it over carefully. Refresh your memory with regard to the major oceans, understanding that this is the Pacific, the Atlantic, the Indian. Certainly know the continent names, and also maybe take a relatively close look at the location of some of the world's most important countries. You don't have to commit them all to memory, but if you give that map a glance and spend about maybe 10 or 15 minutes on it, I think a lot of you will prepare yourself in really remarkable ways for doing much better over the course of the next 3 weeks. Okay, let's move on. I have another example of a reference map that I would like to show all of you. The only difference between this map and the map that I just showed you is that the scale changed. This is basically a close-up view of northern Africa and what we typically call in the United States the Middle East. So this map is actually a larger scale map, but we'll be learning about that in just a few minutes. But again, it's a reference map because, again, there is not a lot of information shown. Just the countries, their relative sizes, their relative shapes, and how the countries are related to one another in a geographical setting. In contrast, this is a good example of a statistical map. Notice that this map has basically a data set behind it. Let me explain. The first clue that this is a statistical map is that you have a legend right here. And what's being mapped here is the percent of the population that identifies as Muslim. So someone had to collect data. So to give just an example here, let's follow my cursor over to the country of Egypt. Egypt is color-coded with a light blue, and if we interpret that correctly, what that means is that somewhere between 86% and 100% of the Egyptian population identifies as Muslim. And so an overwhelming majority of the population in Egypt does. Other places, in contrast, like let's say Mozambique, over here, or maybe way up in the upper right-hand corner, Mongolia, or perhaps way over here into southeastern Europe, Bulgaria, they're color-coded yellow. And what that means is that a comparatively small share of the overall population, somewhere between 5 and 15%, identifies as Muslim. So the point then is that this map, unlike the reference maps that we just got done looking at, is attached to a data set. And the point of the map then is to show the geographic pattern of how that data is expressed. Let me give you another example of a reference map. This one perhaps is a little closer to home. It's a map of the United States. And what it shows is actually a huge Herculean research effort where linguists sent out surveys to people who live in every one of the roughly 3,000 counties in the United States. And they asked them, what do you call soft drinks? Do you call it pop? Do you call it Coke? Do you call them soda? Or do you have some other name? And it turns out there's a really striking geographic and regional pattern whereby, for example, people up here in the northeastern part of the United States, almost all of them typically refer to soft drinks as what? Soda. Across the American Midwest and really across the entire northern tier of states, people, generally speaking, refer to soft drinks as pop. And in the American South, all the way through Texas to even parts of New Mexico, generically people call soft drinks Coke. So, why is this an excellent example of a statistical map? Because again, there's a huge data set behind the map. And the map then, of course, has one job to do, and that's to show how the data is expressed geographically. Now, we're going to talk about regions a little later on, but I want to just point something out. Look here to Wisconsin. Interestingly, with regard to how Wisconsinites call soft drinks, there's kind of a split between the eastern one half of the state and the western one half of the state. We're going to address that issue a little later on in the second video when we revisit this map. I've got just one more example of a statistical map to show all of you. This map right here is in fact very typical of some of the maps we will look at over the course of the semester, insofar as it comes from the United States Department of the Census. What this map shows is population increase and also population decrease in the United States between the year 1990 and the year 2000. If you look over here at the legend, again, remember the legend is typically a clue as to whether or not it's a statistical map. You can see the legend does two things. If the county experienced a population increase, it's represented with intensifying darkness of purple. So the darker purple means that there was pretty dramatic population increase. In contrast, those areas that experienced population decrease, it's represented with tan. And the darker the tan color shade, that means you've got a much more dramatic decrease in the population. Now, if I were teaching this in a face-to-face type setting, one of the things that I often do is ask students if they can interpret the geographic pattern. What do you see when you look at a map like this? And inevitably, students will point out this. They'll point out, for example, that there seems to be a strong arc of territory right through the heart of the country, basically corresponding to the Great Plains, where it looks like almost all the counties are experiencing population decline. Well, we'll actually address that issue later on in the semester. In contrast, there are areas where the population is just booming. For example, here in the American Southeast in North Georgia, there's a collection of counties, all of them color-coded with the darker shades of purple. That corresponds to metropolitan Atlanta. And over here, the same thing is true. That's basically the Colorado Front Range, or metropolitan Denver. And then way over here you have an area with a lot of relatively fast-growing, in fact very fast-growing big cities like Phoenix and Las Vegas, Nevada. But again, the main point, quite clearly, there's a huge data set behind this map, and thus the word that we will use to describe a map like this one is it's a good example of a statistical map. Okay, let's move on to our second learning objective, and that is the issue of map scale. Almost all of you, probably when you think of map scale, you think of this right here. Kind of look at my where I'm placing the cursor, and you have a good example of what is called a graphical scale. So on a hard copy map that you might have in your glove compartment in your car, inevitably you'll find what's called a graphical scale. Well, that's one way of representing scale, but there are other ways. And so what I want to do here in just a few minutes is I want to explain what geographers mean by the issue of a large scale map versus a small scale map. It's pretty easy to do. Let's just take the two maps that we have here on the left side of this panel. The one on top is basically a map of the entire state of Florida. The other map just below is kind of a close-up view of one part of Florida. It's the Miami and Fort Lauderdale metropolitan area. So if we were to compare these two maps, here's the first thing that I would say. The map of Florida is showing us a larger geographic area, whereas the map that just shows one tiny part of Florida, that would be Miami, Fort Lauderdale, that of course is showing a much smaller geographic area. So almost immediately students think this. They think, well, this must be the large scale map, and this one here on the bottom must be the small scale map because it shows a smaller geographic area. Guess what? It's just the opposite. The map that shows the larger geographic area, what we're going to call that? We're going to call that the small scale map. In contrast, the map that shows the smaller geographic area, the word that we're going to use to describe that is it is a large scale map. Now you're probably curious, why would that be? Well, it has to do with the number that's probably pretty hard to see right here. Notice that each one of these four maps has a number that looks kind of just like that in the lower right hand corner. Let me tell you what those numbers say and what they mean. For the map of Florida, it says 1:10 million. For the map of the Miami Fort Lauderdale metropolitan area, it says 1:1 million. Now what does that number mean? That is another way of representing scale. It's called a representative fractional scale, or representative fraction. It sometimes is known as well. The way that you interpret it is as follows. 1 inch on this map equals 10 million inches in the real world. So it basically shows you the level of reduction or the scale of reduction as you're going from the real world to the map itself. And then over here with the other map, the one just below the map of Florida, 1:1 million, what that means is 1 inch on this map equals 1 million inches in the real world. So this then gives us a clue as to why this map here is the small scale map and this map here is the large scale map. And let me show you how and why. If you think of those numbers, 1:10 million and 1:1 million, basically convert them into a fraction. 1/10 million, and do the same thing here, 1/1 million. Thinking about it that way, you could ask yourself this question. Which of these two numbers is the smaller number? 1/10 million is a much smaller number than 1/1 million, and thus it is the small scale map. So if you see that representative fraction and you think about it as a fraction, whatever of the two numbers is the smallest is going to be the number that represents the smaller scale map. And that then is the science behind what we would call over the course of the semester a large scale versus a small scale map. Alright, we'll see all of you in the next video.